So good afternoon to my talk on the Panama Papers and graph databases. Great to see so many people here. I hope you all enjoyed the coffee break, had some cake, and hopefully you don't fall asleep now due to the nice meal and some drinks. So I will do my very best to entertain you a little bit and also to teach you a little bit. So hopefully when you leave the session, you learned a little bit. Before getting into details, anyone in the room who has not yet heard about the Panama Papers? There is one person, wonderful. So you don't follow news at all? Okay, so I will tell the story. On the other hand side, who of you in the room has at least, who knows what Neo4j is as a graph database? Wow, that's impressive. Who actually has used it? You still have a couple of hands. And who is using that in production? Yeah, there's some people there. Cool. Okay, so this I don't have any kind of, I don't require any kind of previous knowledge on Neo4j or graph databases. I want to introduce that concept together with how Panama Papers worked out. Before going to the talk itself, a little bit about myself. You see on the that doesn't work, fair enough. So on the top of the screen, you already see a kind of small cipher path, which is part of our language to interact with the graph database. And even if you haven't heard anything about that, you will still realize that you can read it. So Stefan works for Neo4j, which is apparently true. I'm one of the field engineers at Neo4j, which means I'm not one of the core developers, but I'm helping customers to get started by doing workshops, trainings, also assisting them with projects in terms of coaching. And I'm also part of the support if things don't go that well as expected. So everything that is to do with the technical side of the product and the customers, that's what I care about in the German-speaking countries. I'm based in Munich, Germany. So since I do speak English today, you will miss my nice Bavarian accent, which I would have in German. Sorry for that. If you get any questions after the talk, you'll see my contact data there. Please just reach out to me and shoot me your questions or comments. Okay, the Panama Papers. What happened? Earlier this year, there was kind of combined publication of a lot of different newspapers on data that has been leaked from offshore companies. Offshore companies is, well, if you're a rich man and you want to basically hide your money for whatever reason, maybe because you don't want to pay tax, or the money does come from channels that are not official, maybe you stole something, or even worse, then you can go to some of these kind of tax paradise islands, somewhere in the Bahamas or in the Caribbean region, in Panama. We used to have some in Europe as well, which are now a little bit less. And of course, if you're a rich man, you don't go there and fund your company yourself. You want to hide the identity. So you basically take a kind of law firm in front of you that does all the actions for you. And one of these law firms was Mossack Fonseca, which is originated in Panama City. And probably one of the employees there, or one who has very deep insight in the IT systems, sent all the data he could grab to public newspapers. That's the big picture of the story. Before going into details, some big kudos to my colleague Michael Hunger. If you know Neo4j, you probably have to know Michael Hunger. He's the most prominent guy probably that we have out there in the community. I've shamelessly stolen most of the slides from him. The rest of the material is based on presentations from the ICIJ, also from some Reddit recording, some publicly available online publications from the ICIJ website. So that's where all the material is originated from. So what happened? This is more than a year ago. Who of you knows Süddeutsche Zeitung in Germany? Some hands go up. So it's a very, very prominent newspaper, one of the, I would say, the three largest in the country. They're based in Munich, which, so if I want to travel to them, it's about 10 minutes from my home. So these guys are known for doing investigative journalism, and they have already some infrastructure in place. So if you want to leak some data from your organization, company, or whatever you do, I didn't tell you to do that. But if you want to, they have a kind of encrypted communication channel that you can supply the data without telling them who you really are. And exactly that happened more than a year ago. So there was a guy who named himself John Doe, and he offered some data. And he said, okay, I'm going to give you a lot of data, but there's some rules. One rule is that data is highly sensitive. So if my name is going to the public, I'm fearing for my life. So I will stay anonymous. There will be no physical meeting ever. We always communicate over encrypted chats and encrypted files. And what journalists do with that data is totally up to them. He doesn't care. He didn't take any money for that, because the investigative journalists typically don't pay for it. So the motivation for that guy was basically he wanted to make these crimes public. Owning a company in Panama or some of these tax islands is not a crime on its own, and that's the real scandal behind that you can do that. But they're almost every time used for hiding something. And therefore, there's a lot of crimes behind that. And then he started to transfer data to the journalists. This was in the first place, some random files of some companies, scanned articles, ownership documents, emails, all the kind of documents you can think of. And of course, the journalists collected them on their local hard drives, and to investigate on them, they used their desktop search. These guys are not IT people, so they just know about desktop search, basically. And the material that came in was more and more and more. Like that. So over the period of a year, that guy delivered more than 2.5 terabytes of raw data to not the Süddeutsche Zeitung alone, but to the ICIJ. Because the journalists at Süddeutsche Zeitung were pretty smart at the point of time. They realized we cannot handle that on our own. And also, a lot of the data refers to all kinds of different countries. So if a guy in Germany would do something bad, the new Süddeutsche Zeitung guys would probably have a good chance to investigate further on that, because they know everyone and know how to make a nice story on that. But if something happens in let's say, Argentina or some other faraway country, you need local people there to write a story around that. And therefore, they got in touch with an organization called the ICIJ. The ICIJ is a consortium of investigative journalists worldwide. It is part, or to be precise, it was part of the Center for Public Integrity, which is a non-profit organization. And ICIJ was a project underneath them. But just a few weeks ago, there was the decision to make the ICIJ a separate entity. So it's also a non-profit organization. From the size, it's basically close to 200 journalists are using that consortium. They work together there on stories. They're distributed over more than 65 countries. Of course, there are countries in the Western world, are almost everyone there, but there are countries in the world where you don't have so much fun as a journalist. Think of countries like China, Turkey, North Korea, Russia, soon US, I don't know. I have a bad feeling since yesterday. And these guys work together there. They have conferences, so it's like a conference we do here. They meet up and discuss stuff. The staff of ICIJ is pretty small. It's 12 people who work there full time, and out of the 12 people, it's 50% who work on data and do data research. So apparently there were 6 people working on that huge amount of data. So what did they do? Basically, they had delivered a whole mess of data. It consisted of emails, it consisted of Word documents, Excel, Access databases, and all the fun, and also a huge amount of scanned documents. Yeah, and this stuff needs to be somehow processed. So from these raw files, you need to first extract text, also extract metadata, and then store that somewhere in database or multiple databases, and then provides an easy-to-use tool for the journalists to do some queries on that. And by queries, I don't mean that these guys type SQL or any fancy query language. They want to have like a Google search thing where you just enter names or something like that. And also, the journalists built up kind of list of prominent names in the country. So they tried to get all the members of parliament from Germany, for example, plus the government guys and all the guys who had a kind of history in doing some bad stuff with money. There was this president from our local football team, FC Bayern München. You probably know him, Hoeneß. He's not part of the Panama Papers, but he's sure on the list to do investigations on that. Yeah, and this stuff is then put in a database. The amount of data, it was about 3 million files that were transferred there. And for doing the text extraction, they used the OCR software called Nuix, which is, I think, based in New Zealand. They got free licenses to do that. And they spun up 35 something servers on AWS. And the average processing time was about 10 seconds per file. So it took them 1.5 weeks. If they had just one server, it would be way more than a year to process that amount of data. Okay, so that is a kind of screenshot from this tool they used for collaboration and search for the journalists. Of course, this is massively hidden behind VPNs and all kind of security infrastructure, which I don't know, and there will no one really talk about that. It is based here on Blacklight. Blacklight is an open source collaboration tool which you can use and customize for these things. So there's a kind of forums where you can collaborate together, joint editing and all that kind of stuff. What you can do here as well is you can act on a full text database. ICIJ decided to use Solr. Solr is very prominently known. It's based on Lucene, so you can use Lucene syntax, so you don't need to name names exactly. So there's fuzzy search possible. You can do proximity and all that kind of stuff. The full stack they're using, or most of the stack, to extract the raw data, as mentioned, they use this OCR service. Then to get some insight in the text, to understand the semantics, they used some software they've written on their own. It's available on GitHub called ICIJ Extract, which uses most prominently Apache Tika and some other tools. On top of that, a huge amount of Python scripts. The databases they used was mainly Apache Solr for the full text part, Redis for keeping the reference to the raw documents, and Neo4j to connect the data. And this is what I'm going to focus on. On the application level, we already seen Blacklight, and there was another tool used, Linkurious, which is a graph visualization tool that runs on top of the Neo4j database. Linkurious would look like that. So on the left-hand side, you have also a kind of query interface where you can type some names or specify what you want to find. And then a full-text search is triggered, retrieving some nodes, and then you can explore the environment. You can drill into the data by double-clicking, then the next node opens, and so on. So by that, you can understand, okay, we have here a person that owns a company, and in this company, his wife is also involved, and they own another company. So you can close the circles and get more insight in the data, which you wouldn't find by a pure text search only. So it's about the context of the data. Without using graph technology, we would have boring, disconnected documents. You would have kind of data, isolated data pieces laying around somewhere. Consider that is what you get when you store these pieces of data. So you have various things. people, emails, documents, entities, companies. You have some data with them, properties like name, some values, and so on. And the interesting data is, how are these things connected? So if we add relationships to them, so that this person owns that company, the other one acts as an intermediate for that company that is living in a certain address where a lot of other companies are based, then you get a good insight in that data and you understand how that thing is structured. Let's talk a little bit about Neo4j, the leading graph database. What we use as an underlying data model is the so-called property graph model. The property graph model consists basically of 4 building blocks. The first building block are the nodes. Nodes represent the entities in the real world. So everything that is a thing on its own is modeled as a separate node. On these nodes, we can store properties. Properties are key value pairs. So for example, you have a node, here the left one, might be a person with a name of something. That would be the property. And you can also, the next building block are the labels. So on the nodes, to indicate a kind of group membership, you can assign a label to them. Most people would use the type of that node as label. So the nodes on the top might be a label of person. The node on the bottom might carry a label of entity or company or something like that. The last building block are the relationships. The relationships basically put your entities in a semantic context. So the person knows another person. Relationships always have precisely one type, and they have always a defined direction. Be careful, the direction does not imply the search direction. So it's the semantic direction of that relationship. So if I work for a company, I can traverse from myself to that company, but you can also, at the same speed, traverse from the company back to myself. So it's pure semantic thing, the direction here. What are people typically using Neo4j for? So we carefully listen to people who are using us. We basically identified that we have a lot of projects focusing on company internal applications which are not public-facing. On the other hand side, we have also customer-facing applications. So the internal applications are typically things like master data management, which is mostly about connecting different data silos in established enterprises which don't know each other. If you consider any project that has to deal with a network structure or let's say a logistics network or something like that, that's pretty obvious also a graph thing. Not so obvious is things like fraud detection. Consider in a kind of financial system, you have all the people and companies represented as nodes, and the money that flows between them is modeled as a relationship. By that, you can easily identify things like money laundering, because then money is flowing in a circle. So you're searching for a closed graph structure, for closed path. On the customer-facing side, we see a lot of people using real-time recommendations. That's typically in an e-commerce case where you want to see, okay, in my history, I bought these 5 items, and now let's look what other people have purchased these items, and let's see what their additional behavior was. And this is something we can aggregate and filter and then probably propose as the next purchase for me, myself. The big difference here is it's about real time. Most of these recommendation engines typically work nightly in a batch mode. So they consider only historic behavior, but not session data. So consider you just write a very negative comment on a product, which would be based on the nightly batch run, a recommendation for you. On the next page, you get recommended the thing you just wrote a nice rant about as a recommendation. That kind of sucks. And if you can take session data into account, that helps a lot. The reason why we can do that is because everything in a graph database is optimized to jump from one node to one of its neighbors as fast as possible. We've measured on a single core up to 6-7 million operations per second, which gives you a massive traversal speed. Graph-based search, this is also what we do together with Panama Papers. It's about you start off with some full text search, and then the nodes or the things you find from full text are the starting points for drilling into the graph. So by that you can do questions like, well, which of my friends in New York can me recommend a sushi restaurant, which involves a geographic graph with New York, with continents, with cities, which involves a kind of category graph, restaurant type sushi, which is Asian, which is food, and also the social graph, friendship. Okay, so what is a graph database about? A graph database is about basically persisting data structures in the form of a graph. So it's about writing graph structures and also about reading graph structures. There is a difference, there's a lot of different graph databases out there. We need to distinguish so-called native graph databases, which implement from the storage layer all the stack up on their own in the knowledge that we have to deal with graph data. On the other hand side, there are also non-native graph databases which use existing storage technologies like, let's say, Cassandra or something like that, which does not know about graphs, as a ground-laying technology, and therefore, at some level, they need to map graph to some other format. And on that level, you typically lose performance. So, as mentioned, the core operation is to quickly traverse relationships. It's since we don't have a fixed schema, this plays very nicely with kind of agile approaches where the domain changes frequently. You know these cases when your product owner comes over the corner every other week with a complete new different idea set. And you need to change the data model a lot of times. This can really help you in that context. Also, in terms of performance, just please raise your hand if you have handwritten a SQL statement containing more than 15 joins. There are a few hands. Okay. Was this fun to write that statement? Okay, most people object. Was it, consider half a year later, you need to revisit that statement and apply a change to it. Is that fun? Not at all. So SQL is basically, in my opinion, well, writing might be okay, but understanding a complex statement later on is, at least for me, almost impossible. And also in relational world, you have always to mess around with two different models. You have the logical data model, which in most cases is a kind of graph which you draw on the whiteboard with circles and arrows, and then you transform that into tables. Remember these 4 normal forms of relational database theory and all that kind of stuff. So you have a persistence model. And in the persistence model, you write your queries. When you need to change the query later on, you need to transform that query, written query, back to the logical data model, apply the change there, and jump back and apply the change back to SQL. So you're always jumping back and forth between these two models, which is cumbersome. In graph database world, we only have one model. So the logical model is the persistence model. A few operational aspects. One focus that we have is Neo4j is easy to use. I will show this later on in a demo. Schema is something that we consider optional. So there is no fixed data structure, so you can add new relationships at any point of time. If you learn about new facts, you just add them. There is no alter table or something like that. It is highly scalable, so we can build up of clusters of tens, hundreds of machines right now with the new clustering technology in 3.1. And it's also a transactional database. If you only work with relational database, that's boring because every relational database is transactional. But a lot of non-relational data stores weaken the transactional guarantees for tweaking a little bit more performance out of that. We think that your data is valuable, and therefore we strictly transactional guarantees on that. Okay, one thing on data modeling is this whiteboard friendliness. This relates back to that we only have one data model. So if you ask one of the, would say, domain experts, or here that must be a guy from the business side because he wears a nice white shirt. If you ask these guys to explain you the domain and give them a pen on a whiteboard, they will in most cases start drawing circles and arrows. How is the thing structured? If they start drawing tables, then they've worked too long with relational databases. And that kind of structure is our data model, which gets then into the database directly. So there is no mapping between that. And therefore, these modeling sessions together with the domain experts are also extremely worthful to build up knowledge on your own, because you need to know the language these guys are talking. You need to understand the concepts to build the software in the right way. So it's super helpful for communication. Let's go a little bit more in technical detail here about patterns. Neo4j, the most important part to understand Cypher language is to understand patterns. And patterns can basically be inferred from the graph model. So consider we have here a small subgraph where Dan knows Anne. Cypher is intended to be ASCII art like notation, which means if you consider a node, which normally I have the whiteboard here, but currently we don't. So a node is drawn as a circle on the whiteboard. In ASCII, something similar would be opening and closing parentheses. That makes a node. An arrow, which you draw on the whiteboard, in ASCII art would be dash dash larger than. And this is what you see here. And of course, we need to, inside the parenthesis, we need to specify that this node is a person. So the colon person means that node carries the label person. And in the curly braces, you have the properties in a JSON-like notation. So that is a person with a name property called Dan. And between the two dashes, we have the specification of the relationship. So you pull the two dashes away, insert square brackets, and then you write here the relationship type. So we're looking here for Dan, who knows a person called Anne. That is a pattern. Now we need to put that pattern into some query language constructs. So in the front, we write the word match, which means find me that pattern. And then we have on the end the return clause, return who. So the person here it's no longer Anne. It's basically the question is which people does Dan know? So we only have the constraint here that the other end of the node's relationship needs to be a person, but no restriction on the name. And that node is referred with a kind of variable name, who, which is only valid in the scope of that query. And then we return the who node. So the return, if you take the bridge to SQL, what in SQL would be the select is the return in Cypher. The match is somehow the from part. So how is the world connected? How is it connected? The joins, basically. Okay. This pattern, we can use it in a match to find something, but we can also use it with create to create nodes and relationship. And the same path notation applies to that. And there's another clause called merge. In a lot of cases, you don't want to unconditionally create something. You only want to create something if it doesn't yet exist. Consider in the Panama Papers, so we have the first document on a new company, and we create a node for that company. That company is registered in an address, and we don't know if that address is already in our data set. So for creating the address, if we would just use a simple create, we would end up with having that address node multiple times, which is kind of stupid. So with a merge, you prevent duplication, basically. So it's a lazy combination of match and create. So it first applies a match, and if the match doesn't succeed, it triggers a create. With the set clause, you can change a node. So you can add properties, you can override properties, you can set new labels on things. Delete is obvious, we can delete something. Remove is for removing properties, basically. When you want to find something in the graph, in a lot of cases you want to apply filters. Therefore, you can use the where followed by a predicate that might be matching some properties, matching some paths, or there's a huge variety of things you can do here. Where it made sense, we took over a little bit of syntax from SQL. Here, for example, if you want to do order a result set, you can do it with order by. You can do pagination with skip and limit. And at the end, of course, you need to kind of return. You can do aliases to rename column names. A very powerful thing is the with clause. The with clause is kind of similar to the pipe symbol on the Unix shell. So the output of the first part of the statement acts as input for the next part of the statement. So the with allows you to structure your statements into multiple steps, and also allows you to terminate certain branches rather early to get more performance out of that. Unwind is if you get a list of things, a kind of collection, and you want to convert a collection into a number of rows. So you want to split up a collection. That's unwind. A very powerful thing, and I think the most easy way to get data into Neo4j is load CSV, which allows you to load CSV files directly. I have a little bit more on that. So load CSV operates on a functional database in a transactional way. So in the example here, we load CSV with headers, which means our CSV file, the first line contains headers from a URL. A URL might be a local file, it might be HTTP, HTTPS, or any kind of URLs which your JVM has a URL stream handler for. And then for each of the lines in that CSV file, we merge a person node with the name column of the CSV mapped to the name property, and the age column of the CSV is converted to an integer and stored as an age property. So properties can be strings, numeric stuff, booleans, arrays. And so at the end of the day, for each line, we have one person node. So that load CSV works nicely for small and medium data sets. If you go, I would say, beyond 10 million or even in the hundreds of millions, there are other tools to, before getting to that, so there are other tools to import. In the same way you can import CSV, you can also work on JSON data directly. I leave off the details since we're a little bit short in time already. If you have a huge amount of data and you want to have a kind of initial data load, there is also a kind of batch inserter. Be careful, that tool does not work while the database is online. It creates the initial database for you in a non-transactional way, and you can work there with billions of things in a rather performant way. So we can create millions of nodes per second with that tool. But your CSV files need to fulfill a certain format. Okay, let's get back a little bit to the Panama Papers. So in total, over all the data collected, they identified more than 35 people who either are in a leading position of a country or used to be in a leading position of a country that are part of that data set. If you remember, do we have someone from Iceland here? No, I don't see one. Sorry, I cannot see anyone because of the lights here. But the former Prime Minister from Iceland needs to resign his job because he was part of the data set. So he owned a company, and I think a few days before he became Prime Minister, he sold that company for $1 to his wife. And that was not legal, and Recently, they had also a kind of election in Iceland, which caused a kind of big change in politics there. There's also a big friend of Putin is in the data set. You see Prime Minister of Azerbaijan, Aliyev, holds a couple of companies. I think the chief of state of the Arab Emirates is part of that, and some more. So what did they do basically with it? First all the steps for the document analysis. They first acquired documents, and don't underestimate that if that amount of data, if you need to transfer 3 terabytes in small pieces in an encrypted way, that is work. And then you need to classify the documents. You either do scan or OCR, extract metadata, and then do identify domains and questions on a whiteboard, extract entities and their relationships based on text analysis, think about what properties do you want to store. Also, the data set not only consists of that leak, they also have the offshore leak data set, which was leaked before, merged into that, so they have different data sources. Then you need to think about analyzers and all that stuff. You need to care about getting the metadata in. And point 6 is interesting. You can infer relationships. So inferring relationships, let me make a simple example. So I work for Neo, which is a company of 130 people. So I have a works for relationship with that company. And here in the room, there is a colleague of mine, Konstantin. He also works for that company. And now we can apply a rule that if 2 people work for a company with less than 150 people, we assume they know each other in person. So we can infer a nose relationship between me and Konstantin. So you can apply this kind of logic to closed triangles. And so with that is a technique to basically unveil hidden data. And then you can apply calculate similarities, because sometimes names are not written in the exact way. So if you think these people are the same, you make a same relationship between them. And then you can go into visualization and do some analysis. So that is the flow that the guys did. So the data model, so potential entities they're working with is, well, you have people, you have representatives, you have addresses, you have companies, you have accounts. So meta entities would be kind of in which document was that located, contract numbers, author dates, and all that kind of stuff. Potential relationships, think about I own a company, I have shares, I manage a company as general manager, I opened an account, the company has a registered address somewhere, money flows and so on, family relationships. That's roughly the domain that they're dealing with. So that would be a kind of snippet of the data model they worked with. So there is a client, registers a company, then there is an officer, which is a kind of shareholder of that company. This is only a short excerpt. So these kind of models you build up when you try to understand the data structure. Yeah, the data model they used, as said, was rather simplistic. Think about it was only 6 people who worked on that. So it's about 4 kind of entities, a few type of relationships. And the ICIJ released a subset of that data to the public directly as a graph. Of course, they scraped the data. They removed sensitive data like credit card numbers and other stuff. And on that data set, we can run now some queries. That data, of course, misses a lot of information like metadata, family relationship. It contains a lot of duplicates, so it's not really cleaned up data, but it's good enough to do something on it. So if you had way more resources, you could easily refine that kind of thing. So let's go to this example data set. So So here's my Neo4j instance. Yeah, that looks good. I think I should have made it a little bit larger. So what you see here is I've started a Neo4j instance using the Docker container Well, every talk on this conference needs to have the word Docker in it somehow. So what you see here is the Neo4j browser. The Neo4j browser is a tool that is intended to be used by the developer or by a domain expert who wants to write ad hoc queries. It's not something you want to expose in a project scenario to the end customer. So what you see on the left-hand side, there's a few panes, like here, the database vocabulary, so we know here which labels are used, we see which relationship types are used, a couple of them, which property keys are used, we see the size of the database, and some other stuff. We can, on that, the star is basically for queries, so you can store your queries that you once wrote in the browser to reuse them later at a later point of time. There's some links to documentation, some tutorials and all that kind of stuff, and some more which I don't want to cover right now. So the mechanics is here on the top line. I can enter a Cypher command, and for every time I enter a command, I get a response box. The response might be an error message like now, or it might be a visualization consisting of nodes and relationships, or it might be a table-like result set. What the browser also has the capability to render guides. So guides are HTML files in a certain format that you can easily view in the browser. So here, for the Panama dataset, we created a kind of guide for the Panama dataset. I don't want to go through all of them, but the investigative queries is interesting. So these guides contain a little bit of prose text, some images, and when you see these cipher blocks, when you click on them, you can directly execute that. So there is a function to extract the meta model of that graph. Let's try to get that. So we have here, an office, so this is the meta model. So an officer might be shareholder of an entity might have an intermediary, an entity and an officer might have a registered address. And then there's similarity relationships for all the three entities. That's the meta model. And that's nowhere explicitly stored. That's just calculated from the graph. Okay, let's do a kind of query. We want to understand, we want to look for intermediaries which have more than 100 relationships to whatever, and want to filter so which intermediaries host the most companies. And here you see a lot of company names, and here is the famous law firm Mossack Fonseca, which was the source of the leak. By the way, there was recently, a few weeks ago, I heard in the news that Mossack Fonseca has to lay off a couple of people. Normally, I'm always think about, well, the people lose their jobs now. But in this case, I'm really happy about that, to be honest. So they're almost done, I think, with their business. Okay, let's go a step further. So, let's get some visual results. So let's assume we want to find intermediaries that act for companies. And so we have here the path would be, so we're looking for a node with label intermediary. We name that node I. We're looking for an intermediary of relationship to something that is an entity. I know that variable names should consist of way more than one character. In real code, I do that, but I would just break the line here. So this is a rather bad example here to have only one character variable names. And the intermediary's name property should contain the word Mossack, and the jurisdiction of that entity should be the Seychelles Islands. And then we just want to return the intermediary, the relationship, and the entities, and we want to limit that down to 100 results. And you get here now kind of visualized results because I've returned nodes and relationships. And then you can go grab any of these nodes, you can move them around. If you double click on them, you explore the environment of that. So we have here a guy called Mr. Lars Erik something, Erik Larsen. And that one has a registered address in, where is that? In Myanmar. Okay. So that is a way how you can interactively drill into the graph. So that guy is already in relationship to 3 companies, Raffles, Netco Limited, Privilege, and so on. Yeah, that was already pretty useful. So we can also return tabular results. So this was kind of graph view. That is nice for exploring the data, but in a real application-like context, when you write an application that uses the graph database under the hoods, you want to have kind of projections. So you want tabular results which you can iterate over. So that would be an example to, so we want to list officers that are beneficiaries of entities, and we want to find out which officer has the most, and it's related to most entities. And therefore, we apply a count aggregation, and we order by the count, and we cut off after 10 and in order descending. So this gives us the 10 people or entities who are related to the most companies. And here you see already the data is somehow a little bit shitty, so it's not really scraped, but good enough. Okay, what we can do as well is, so if you want to find a certain officer, so let's do this guy from Iceland, Gunnlaugsson. This was the former prime minister. And here we see him, and if you look at the bottom, you'll see all the properties of that node. So here you see Sigmundur David Gunnlaugsson. Let's just open that guy, and you see there's a company called Vintris Incorporated, and he has a registered address somewhere in Iceland, Lokatiskur 24. So if you've ever been to Iceland, go there, have a coffee with him. And on that address, there's another person registered. It's his wife. And he's also shareholder of that company. Okay. So any specific name we should query right now? Trump. Let's just try that. Yeah, it's Pacific Trump Enterprise, New Trump Technology Limited, Trump Tech, and so on. So it's not related to that person in the US, as far as I heard. I think the journalists have spent a lot of time to find him there, because that would probably change yesterday's results, but he was smart enough not to get into the dataset. Okay, next one. We want to. So far we just did a kind of lookup, and now we want to find an officer which name contains Trump, and want to return back the entities he owns. So we have a kind of match here that already does some traversal. And these are the 3 companies, or the 3 officers. Officers might be companies as well. Yeah, there's more queries. I think I'm gonna go a little bit faster now, because I want to show you something rather interesting. Let's do a kind of query here. So who's involved as well? So we want to find the pattern here is we're looking for a node that is an officer that has a relationship to a company or an entity that has a relationship to another officer. And then we filter out that the officers must not contain the word limited, because we're interested in natural persons. And that these officers should have, each of them, more than 2 relationships. So which 2 pairs have other companies on the side? And then we do want to collect them and get some nice report out of that. That is already pretty complex, because it is a kind of global query. It goes through the full graph. And Here you see there's Mr. Chung Win Tuck Douglas and Mr. Chung Kar Hyun Henry. Sorry, I cannot really. And they are involved in that amount of companies. And I think if you are associated to multiple companies, the likelihood that you're doing something illegal is even higher. Yeah, another interesting thing. So far, we did not do a lot of. So we started our query somewhere and we traversed the path, which consisted of a few relationships. But what we didn't do so far was something from graph theory. What we easily could do in a database like Neo4j, so we have one person and we have another person, but we don't know how they are related. And we can probably ask, what's the shortest path between them? So how does the relationship look like? And what I'm going to do here, so we have Mr. Smith and Mr. Grant. So we look them up in the first place. Because there's multiple of them, we limit that down to 20,000. And then we want to find all the shortest path based on officer, intermediary, and registered address relationships up to a depth of 10. So we can do variable path traversals. And we want to get back 50 results right now. That takes a few seconds because it is a complex query already. Okay, some background music, blah, blah, blah. Come on. When I tested it up front, it was faster. Okay, anyway, while we're waiting for that, I do have stickers here. So if you want Neo4j stickers or these wonderful graphs are everywhere stickers after the talk, just grab them here. Yeah, here we go. Also, and we can now zoom that a little bit. Got down here. And we have here intermediary. Cloud 9. Here is Stuart Onslow Smith, and there's Stuart Grant. So that would be and here is this other guy. This is Grant Moate Kim. So this would be the shortest path. So you can easily follow over which, and there's multiple shortest paths, of course. So how their relationship is structured, and then you can probably get more details on the companies. So this is how you find out relationship between people. Yeah. So I think I'll stop the demo at that point. To have a few minutes left for questions. I do have a kind of announcement which was just released today. So my employer, Neo Technology, today announced a new finance round, Series D, with 36 million in the bank. So that was impressive news today. Was just released on 1:30 this afternoon. So that is the kind of announcement, and then according to the time here, we have 7 minutes left for questions.
Do you have any features in API to report progress on search?
So the question was, do we have any feature in the API to report progress? Not directly. There is a way to extend Neo4j with your own JVM code, and with that you can write a progress indicator. And it's hard to do that because you don't know the result set up front. What you can do with an extension is say, I have this query, and run that for, let's say, 10 seconds, and finish it then, and just return back what you found so far. That is, there is a very valuable extension to Neo4j called the APOC library. And APOC, A-P-O-C, this was the kind of mechanics guy from the Nebuchadnezzar in the Matrix movies. So that library features that kind of thing. Okay, some more question? There, I can hardly see you due to the light. Yep.
Yeah. Can relationships have a weight or a strength?
Yes. So the question is, can relationships have a weight or a strength? You can put any kind of properties on the relationships in the same way you can put them on the nodes. And typically on the relationships you store meta information, like when has this thing been created, or a weight, consider a logistics network. So the road between Brussels and Antwerp is 40-something kilometers, I assume. So then we would have a weight of 40. And you can use these weights then for weighted shortest path based on the extra algorithm or A star to do route calculation. More questions? Just shout at me, I can hardly see you. Okay, there's a question. Please, go loud. The question is, how do we handle time in such a graph? So there is no separate type for date and time in Neo4j as a property type. Every time you deal with date and time data, you can store it as milliseconds since epoch, so the Unix timestamp. And the epoch library I just mentioned has capabilities to format that back to human readable time. With index operations, I didn't cover indexes at this talk at all. With index operations, you can do range queries on these time properties. And by that, you can get everything that happened between that time span. Another approach to that is you model time explicitly in the graph. So you have a kind of time root node. Underneath, you have a node for each year. Underneath, a node for each month. And then you go down as granular as your domain model mandates, maybe to minutes or something like that. And everything that happens at a certain minute is then connected to that time node. And to find, then do a range query is just, you need to traverse down the time hierarchy and grab everything that is underneath. There is an extension to Neo4j from our partners GraphAware called the time tree. Just inspect that web page. There's another question?
How to do history in a graph?
How to do history in a graph. This is not a built-in feature, but you can tackle it nice with modeling. So there is, what you basically do, you separate the entity from the state. So each entity is a node, and the state of that entity is a separate node. And then you have a has-state relationship between them with a timestamp from and to. And when the state changes, you take a copy of that state node, change the old state from current time equals to current timestamp, and then the state nodes might have a next relationship. So you have a kind of, they are around the entity node, basically. And by that, you can track every change and do historization. There is a great blog post of my former colleague Ian Robinson out there. Just Google for Neo4j time version, and you will find that blog post. It's a very, very good description of the concept. So you basically tackle it by proper data modeling. But take care, every query will get much more complex due to that. Another one?
Do you have a concept of paging to limit the number of nodes you want to retrieve?
Do we have a concept of paging on the number of nodes we want to retrieve? Of course, Cypher has a limit function, so you can ask, give me just 100 things, and then done. Yep. Okay, so I do have some stickers left. Please, I'm around this evening and maybe tomorrow, so grab me for questions. Thanks a lot for attending.